In this video we are going to study about what is meant by position, velocity and acceleration. See, what is position? Whenever we study about any body, then one of the basic properties that we are interested in is its position in space, where the body is located, and not only this, we are also interested in the fact that how the location of body is changing, at what rate the location of body is changing with time. Get your point? So whenever you wish to locate a body, suppose you have a particle over here, say somewhere over here in space, and you want to specify the location of this particle. In that case, we want to specify location in, say, 3D space, 3-dimensional space or 2-dimensional space, depending on the problem you are working on. The problem can be 2-dimensional also, the space can be 3-dimensional also, and sometimes space can be 1-dimensional also, right? So suppose we want to locate this particle, suppose P is the particle, right? So P is the particle and we want to locate the position of this particle. We want to locate the particle, or locating the particle means specifying the position of particle. Position is a physics word. Okay, that means locating a particle or determining position is same thing. So I want to specify the position of this particle. So whenever you wish to specify position of any particle, you have to take a reference. You have to take a reference from where with respect to which you can write the position of particle. For example, if somebody says where is India Gate, right? Where is I am in Delhi, so I say where is India Gate or where is Delhi University. Then I have to if I say what is the distance of India Gate, then distance of India Gate means you have to write distance with reference to something, right? The next question you will ask you from where you want to measure distance, because distance or displacement, I'll come to displacement also. Whenever you wish to find, say, distance of point P, then distance of point P has to be answered with reference to something, like distance from this point or distance from this point. That's why whenever we talk about distance, we talk about first reference with respect to which I'll tell you the distance. So we must write, we must first find out the reference, with reference to which point you want to measure distance of point P, with reference to which point you want to get the distance of point P. So we have to get a reference, right? So suppose the reference is O, and we take this reference as origin and draw a coordinate system. We draw a coordinate system. So I am drawing it a 3-dimensional coordinate system. So we can draw a set of orthogonal axes, and we say this is X, this is Y, and this is Z. And now once we draw these axes, we can specify the position of this particle here with reference to these axes. With reference to this axis, we can write the position of this particle P with reference to this axis. Or better, first of all, I'll tell you how we write the position in 2-dimensional coordinate system, right? That will be easier for you to understand. So first of all, and then we can generalize to 3-dimension. So suppose I want to get the, yes, so let's try to specify the position in 2-dimensional space. Most of the time in physics you are working in 2-dimensional coordinate system only. Suppose this is X and Y are the axis, and now we want to specify the position of this particle P, right? So position of this particle P has to be written with reference to this coordinate system, So whenever you wish to write the position of any particle, you have to write it with reference to certain coordinate system. So what I have taken is Cartesian coordinate system. And it may not be first octave, it can be like this also, right? This is the coordinate system. So position of particle is written with reference to this coordinate system, So we can specify, we can completely describe the position of this particle P by getting the distance of this point P, distance of point P from the y-axis. The distance of point P from the y-axis is taken as, suppose this is distance of point P from the y-axis, we take it as x coordinate. Distance of point P from the y-axis taken as x coordinate, and then we see the distance of this point P from the x-axis, and that is taken as y coordinate. So this is x coordinate and this is y coordinate, right? So you can specify the position of the particle by writing these coordinates, right? Or you can also specify the position of this particle in terms of vector also. We can have a vector notation for writing the position of this particle, and in terms of vector, we can just draw a vector from say from this origin till this point P. This is a vector, and we call this vector R vector, that is called position vector. That's called position vector of particle P or point P, and that is written as R equals to xi cap and yj cap. What is I cap? I cap is a unit vector in direction of increasing x. It's a unit vector in the direction of increasing x, and j cap or I cap is a unit vector in direction of positive x, and j cap is a unit vector in direction of increasing y or positive y axis, right? I cap is unit vector. Unit vector means a vector having magnitude 1 is called unit vector, and vector so I cap is a unit vector in direction of positive x axis, and j cap is a unit vector in direction of positive y axis, right? So this vector can be written in component form as xi cap plus yj cap. What is xi cap? I can write xi cap. Xi cap is this vector, x magnitude, this is xi cap, and this is yj cap, and sum of these two as per triangle of addition gives you R vector, right? So once you get the coordinate of point P in this two-dimensional space, suppose the coordinate x and y, you can write the position in terms of vector also, like xi cap plus yj cap, right? And you can generalize it to 3 dimension also, but I am not right now going to 3 dimension. Most of the time you work in 2 dimension only, but this can be generalized to 3 dimension as well. So this is how we we specify the position of particle P. So you must understand one thing: whenever you wish to specify the location of any object in your real life also, I gave you example. If suppose somebody asks you that where is India Gate, then you have to specify the position of India Gate with reference to certain certain point, like India Gate is at 10 kilometers from Delhi station, right? So with reference certain, if somebody asks you where is Ram or where is Syam, then you have to ask from which point you want to measure the distance, from which point you want to refer the position of Ram or Syam. So whenever we talk about position, it has to be written with respect to certain reference frame, right? So this is reference axis x and y, and with reference to this we are writing the position of point P. If I change the reference coordinate system, then this R vector will change without particle P getting changed. Suppose somebody says, okay, this is my coordinate system, then for then for this coordinates, if somebody takes this coordinate system, then references got changed, so this coordinate will also get changed. Particle P is not changing in space, the position of particle P is not changing in space, but if I change the reference, the x and y coordinate will change and this r vector is going to change. So position is always written with reference to certain things, with reference to certain coordinate system or reference frame, right? So position is something which have to written with reference to certain coordinate system. Now this is all about position. So position is something which describes the location of particle in space. Position is physical quantity which describe the location of particle in space. Now in physics, in any physical system, the body is subjected to some kind of forces or some kind of influences. Under those influences, under those forces, the position of particle may change with time. The position of particle or this particle may undergo change in position. The location of particle can change with time, right? Location of particle can change with time. So suppose the particle moves in space along this curve, say it has moved like this, means this is the position at t equal to 0 and this is the position at t equals to say t naught. This is the position at t equals to t naught, right? So at t equal to 0 particle was here, and at t equal to t naught particle goes to this position. It is following this path, is following this path, right? So t equal to 0 particle were located over here, at t equal to t naught particle is lying at this point, particle lying at this point. Let's write this conveniently. Suppose particle lies at this point. It will be easy for me to draw a final position vector, right? So this is the position at t equal to t naught. Now in this case, if somebody asks me what is the distance traveled by particle P, what is the distance traveled by particle P, then if somebody says distance traveled by particle P, then that will be length of this curve which is traced by particle from time t to t naught. That will be length of curve traced by particle from length of curve traced by particle from t equal to 0 to t equal to t naught. That is going to be the distance traveled by particle P during time interval t naught, right? Let me remove this Cartesian system. Get your point? That is the length of this curve. Length of this curve traced by particle in t naught time interval. That's called distance. That's called distance. So distance is length. Hence this is a scalar quantity. This is not a vector quantity. This is a scalar quantity. And there is one more term that's called displacement. Displacement of particle P during time interval t naught, right? So displacement is something which may be different from distance, not always but many a times. So displacement, how do you define displacement? See, displacement is, this is your initial position vector, this is your final position, this is your initial position, this is your final position. So initial position is, suppose this is R is the initial position vector. R is a vector which represent initial position, which describe initial position. You can have a vector which is describing the final position. So this can be a vector which is giving you the final position. So this is, say, R dash. So R is the position vector which describes the initial position of particle. R dash is a position vector which describes the final position of the particle. Then displacement is given by R dash minus R, that is a vector with its tail at the initial position and with its head on the final position. That is going to be our displacement. That is going to be our displacement. The vector with its tail at the initial position and with its head at the final position, that's going to be the displacement vector. This is a vector quantity. Getting a point? So if this position is say x dash y dash, then this r dash vector is going to be x dash I cap plus y dash j cap minus, so that gives you plus y dash j cap. That's your displacement vector. That's your displacement vector. So it has got a magnitude. The magnitude is the shortest distance between P and say this is point Q. This is or say P has been taken as particle also. So I write not like P. So you can say the magnitude of displacement is the magnitude of this vector, magnitude of displacement, magnitude of this vector, or magnitude of displacement is basically shortest distance between initial and final position. Shortest distance between initial and final position. You can say magnitude of displacement is shortest distance between initial and you know that in space the shortest distance is straight line distance. Straight line distance between initial and final position. So in a way we come to a conclusion that the magnitude of displacement will always be less than equal to distance. If the body itself is moving in a straight line, then of course displacement distance will be same. But if body is moving in a curved path, then distance will be always greater than displacement. If body is moving in a curved path, then distance traveled will always greater than displacement. Right? If body is moving in a straight line in this along this line itself, then in that case your displacement can be equal to distance if the direction of motion always remains same. If somebody says ki P has moved in this direction, then has returned back to this, in that case if P moves till this position and returns back to this point, in that case distance is still higher, right? Distance is this distance plus again this distance plus this distance, but displacement will remain only this. Getting a point? So displacement is always less than equal to distance. Displacement is always less than equal to distance. Okay, getting a point? So understand the difference between distance and displacement. Distance and displacement. I'll give an example. If suppose a body is moving in a circular path, say if the body moves in a say this kind of circle, right? Body starts from here. Suppose the body starts from here and moves in a circle and come back to this point. Body starts from here and come back to this point again. Then if the radius is r, then distance traveled is basically 2 pi r, but displacement is 0 because the distance between initial and final position the shortest distance between initial and final position is 0, because initial and final position is same. Your x dash x is equal, y dash is equal to y. So this is going to be 0, right? Get your point? So distance and displacement can be different. Okay, so that is about distance. That is about distance and displacement. This is very, very important basic physical quantity that we come across in classical mechanics. Okay, in next video I'll discuss about velocity, right? Okay, thank you.